Hello, and welcome to 5 Minute Math. Today we are looking at the 7th grade concept of volume. This is 7.9a Readiness Practice, the intermediate version. If you are interested in exploring the 7.9a Readiness Practice for the proficient or advanced versions, or the Readiness Practice resource along with any other standard, you can find those by using the link in the video description. So first we have a gift box, and it's shaped like a rectangular prism. All right, so I'm just going to kind of draw a rectangular prism here so we can visually kind of keep track of something here. So I'm going to draw this rectangle, and then the back parts I always make dotted to try to help it make it look like it's 3D. All right, so its base is 21 square centimeters. All right, so when we're talking about the base, all right, we're talking about the side that has the opposite side that is parallel or that is congruent, right? So we got two, look at the name rectangles. So we've got two rectangles. These are our two bases. Now, in a rectangular prism, all the faces happen to be rectangular, but in a triangular prism, octagonal prism, hexagonal prism, you're not going to find that. So we still find this rule. Here's my base, because these two opposite sides are congruent, and it's 21 square centimeters. Its volume is 231, so this is the whole thing. Let's do that in a different color here. So volume equals 231 cubic centimeters. Now another way to rewrite this would be the cm cubed. Another way to rewrite the square centimeters is going to be the cm with 2. So either one of those work. What is the height? So we're looking for this right here, this height. Well, what do we know about volume? Volume equals base times height. Now that base is the area of the base, and they've already given us two of these, right? They've given us the volume is, I'm going to substitute in 231 for my volume. I'm going to substitute 21 in for my B, and then I just need my height. Well, now I can use the properties of operation, right? And I can divide both sides by 21. And that's going to get me what H is. Now let's divide, let's see, 21 into 231. 21 goes into 23 one time. Well, that makes it easy. It's just going to be 11. All right, so H equals 11, but we need a unit. And since we're talking about a single dimension, just its height, right, that is going to be cm. So that is our answer here. The height equals 11 centimeters for this box. Now we have a square pyramid. A side length of 6 centimeters, height of 5. What is the volume? Okay, so I'm going to draw a square pyramid here, or at least it's going to attempt to be a square pyramid. And I'm going to connect it like this. All right, so there's my square pyramid. It has side lengths of 6 meters. Now it is a square, so all sides are 6. So 6 cm. And we could put that all the way around since it's a square. And it has a height. Now, here's the thing with the height. I can't use any of these sides as my height because they're slanted. Height needs to be perpendicular to the ground. If we use those sides, that's actually called the slant height. So what I'm going to do is I'm going to kind of draw this green line here. And it's usually represented like this. And it's got that little right angle symbol right there. And that, assuming that's right, perpendicular to the ground, I kind of swung it out so we can see it so it's not hidden by that first edge there. That is going to be 5 cm. So really, what we need is we need our volume of a pyramid now. It's 1/3 base times height. Now, this is different from the previous problem. They haven't given us the base. They've given us a side length. So this base right here is the area of the base. Big B is the area of the base. So 1/3. Well, what is my base? Well, my base is a square. And so the area of a square is side times side, right? Or side squared. So that is going to be 6 times 6. And so we can say that is 36. 36 square centimeters. Now the height they already gave to us, it's 5. All right, so we could, if we wanted to, multiply 36 times 5 and take 1/3 of that, but I'm going to go ahead and do this 1/3 times 36, because that's the same as 36 divided by 3. And so that is going to be 12. So those two combine into 12 times 5. So I'm going to get 60. Now we need our units back. Let's get cm and cube since we're dealing with volume. So our volume equals cubic centimeters, and let's put a blue box around that. 60 cubic centimeters. So now we have a visual, so we don't have to draw this time. We have a a triangular prism, and we just need to find the volume. Well, the volume of any prism, not a pyramid or cylinder, but a prism, is going to be base times height. Seems pretty simple, but the trouble is always finding that base. Okay? So let's look at the two bases here. It's a triangular prism, which means my two bases are triangles. So this is a triangle, and then this back here is my other triangle. So let's find the area of that triangle. Okay, and we actually have some calculations here. I have an H and a B. Okay, so I'm going to kind of go over that blue with red right here. That's my base right here. And then my height, I'll kind of do that in green. That's going to be this right here. So what do we know about the area of the base? Well, it's a triangle. So first we have to have a separate calculation. So let's go over here and do area equals 1/2 base times height. Now you notice it's a little b. They're both bases in volume and area, but it's a little b because we're looking at just one face. The volume base, the big B, is the area of the entire face right there, whereas this B is going to be a different type of base. It's going to be the bottom part of this shape. This is a triangle. And so I already have all of these calculations, or all of these numbers, dimensions. This B is my 8, and this H is my 12. Let's go ahead and do that same thing. Let's do 1/2 of 8 is 4 times 12. So that's going to equal 48. All right, so we can say that the area of this base right here, let's do that back in blue, is going to be 48, and we're dealing with centimeters squared. So that's the area. I'll put that as a big B because that is what we're calculating. Big B is 48 centimeters squared. All right, so I can plug this back into my original volume. All I need is my height. Now, do not get tricked. This is a tricky problem because I have an H right here. And it looks like that's going to be the height. And if you plug in 12, you are incorrect. The height here is going to be the height of the prism. The prism has two bases. I outlined them in blue. They're the two triangles. The height is the distance between those two bases. And we actually have that right here. So these purple lines are the edges that connect the two bases. And the edges that connect the two bases, that's the height. Just because you have a prism doesn't mean it has to sit on its base. When we looked at our very first prism, it was sitting on its base. Its height was straight up and down. In this case, the prism is sitting on its side because the triangles are off to the side. And the height is the distance between those two. So I need to, instead of using that h, which is 12, I'm going to use the 10 as my h. So let's put that in here as 10 so we can kind of connect the colors. And so I've got 48 times 10, which is going to be 480. And then let's do cubic centimeters cubed. And that is my final answer. That is a little bit tricky, but I think we got it here. So let's just go ahead and put that in blue. And let's just go ahead and put this right here. 480 cubic centimeters is our answer. If you're interested in exploring 7.9a Readiness Practice for the Proficient or Advanced version, or the Readiness Practice resource line with any other standard, you can find those by using the link in the video description.